Welcome to this solution video. If you like this video, please share with your friends and subscribe to my channel and motivate me to make more such videos. Let's start with question number 1. Find the constants a, b and c such that this rational part becomes equal to the other part. So now to find those values, first step should be that we should separate p, q and r with their exponents. So this p becomes p to the power half because square root p is same and this square root is only over p, not with q, not with r. So q is already there, 2/3, r is power minus 3 divided by when we have a bracket and some exponent over it, we should distribute it among the parts which are inside the bracket. They are multiplying, so we can give this to each one of them. So p square q minus 2 r minus 1. Okay, second step should be that p and its exponents are separated. So half is there and 2 is there. But because they are dividing, same base is dividing, their exponents subtract. And this will happen with all of them. 2/3 minus 2 and r minus 3 minus 1. So we get half minus 2 will be minus 3/2 q. 3 times 2 is 6 plus 2. This negative and negative will make it add, so they will add up and 8/3 will be the exponent. Then r is minus 3 plus 1 minus 2. So we got a equal to minus 3/2, b is 8/3 and c is minus 2. Question number 2. A particle moves in a straight line such that this displacement is s equal to 1 plus 3t to the power minus half. So we have to find the exact speed of the particle when t is equal to 1. They're saying speed. But when we differentiate s with respect to time, we get velocity. So what will we do? We'll just find velocity and we'll ignore the direction at the end. If it is negative, we'll make it positive. If it is positive, we'll keep it positive. So just find velocity. So differentiating this will be minus half comes in front. 1 plus 3t is unchanged, but its exponent goes down by 1. And further we have to multiply by the differentiation of what is inside the bracket, which is 3, because 1, its differentiation is 0 and 3t has a differentiation of 3. So it effectively becomes this 1 plus 3t to the power minus 3/2. Now they said find the speed when t is 1 second. So we substitute t equal to 1 in this. So 1 plus 3 times 1 is 3 minus 3/2. So which is minus 3/2, 4 to the power of negative 3/2. So to make it positive 3/2, first make it positive and then whatever is inside the bracket, reciprocate it. So 4 becomes 1/4. So now I'm doing it mentally. You can use your calculator if you want, and we get how much? Minus 3/2, and square root is half, and q will be 1/8. So the answer is minus 3/16 meters per second. But since it is speed, we will write it speed equal to 3/16 meter per second, because negative shows direction and we don't want to know the direction. Show that the acceleration of the particle will never be 0. So acceleration is this further differentiation of velocity equation, which is second derivative of displacement equation. So in other words, we will differentiate the first derivative again, this one. The constant remains constant, but minus 3/2 comes in front. 1 plus 3t again remains 1 plus 3t, but the exponent goes down by 1. Okay, so what do we get here? 9/4. and we had to multiply here by 3, I forgot, times 3, so it will be 27 over 4, 1 plus 3t to the power minus 5 over 2. uh, this this saying should not be equal to 0. It would prove that it is never 0. So let's make it 0 and then show that it has no solution if it is 0. So 27 over 4 is a constant. It cannot be 0, so ignore it. Focus on this one. 1 plus 3t, let's make the exponent positive here as well. Just like the previous part, this one, we reciprocate 1 plus 3 to make it 1 over 4 to make the exponent positive. So I'm ignoring this one now because it is equal to 0. So this, I'm assuming this is equal to 0. So 1 over 1 plus 3t, it is reciprocated, so its exponent becomes positive, and this is equal to 0. Now, to make it a 0, there is no possibility. Why? Because 1 to the power 5 over 2 will be 1, and 1 plus 3t over 5 over 2 equal to 0. And with the cross multiplication, if we do this, will multiply with 0 and 1 will be equal to 0, which is a wrong statement. So we already know that there is no solution. So that means it is not possible for a to be equal to 0. Alright. Question number 3. A function is such that fx is ln 2x plus 1. For x is greater than minus half, write down its range of f. It is ln, nothing is adding, nothing is subtracting, so it becomes very easy. Every natural log or log for that matter, this is how the graph looks like. Okay, even with reflection, it remains going from down indefinitely to going up indefinitely. So since y has all the values from negative infinity till positive infinity, all the values, that means all real numbers are the range, part of the range. So range becomes fx is an element of all real numbers. If function g is such that gx is this, find the exact solution of g fx 13. G fx is also mean g inside the bracket fx, and which can be written as g, and fx is ln 2x plus 1. So in g function, wherever is x, substitute that by ln 2x plus 1, and we have just one x here. So it becomes 5 times ln 2x plus 1 equal to 13. Oh, there is minus 7 also. Minus 7 equal to 13. So 5 ln 2x plus 1 equal to 13, and this 7 goes there, becomes positive. 13 plus 7, 20. Divide both sides by 5. Our focus is to find the x. Okay, so 5 and 5 cancel here. Ln 2x plus 1 equal to 4. Now if we remove ln from here, it means 2x plus 1 here, but the other side becomes e to the power 4. So 2x equal to e to the power 4 minus 1, and x equal to half e to the power 4 minus 1, and they're saying exact solution, so we got exact solution for this. Okay, next, find the solution of equation f prime x. Differentiation of fx is equal to inverse of x, so fx is ln 2x plus 1, correct? So f prime x in this case will be the reciprocal of 2x plus 1. This is what we do in case of ln, and multiply this further by the differentiation of the one we reciprocated, 2x. Its differentiation is 2. So we get 2 divided by 2x plus 1. Now let's find g inverse x. And gx is 5x minus 7. So to find inverse, what do? We substitute gx by just x, and this y becomes, this x becomes y. So it will be x plus 7 equal to 5y, divide both sides by 5, and we got our inverse. This y is the inverse. G inverse x is x plus 7 over 5. Now we have to equate this equal to this, because they're saying f prime x is equal to g inverse x. So 2 over 2x plus 1 equal to x plus 7 over 5. Now to solve such an equation, we should always do cross multiply. So 5 times 2 is 10 on the left side. 2x times x plus 7, 2x square plus 14x. Then 1 times x plus 7 is x plus 7. Let's bring this 10 also to the right side and simplify. 2x square, 14 and x, 15x. 7 minus 10 is minus 3. Okay, quadratic, and we cannot factor this. So let's use quadratic formula. So x equal to minus b, 15 is b for us, plus minus b square 4 times a times c over 2 times 2. Okay, so what do we get here? Minus 15 plus minus is 225, 8 times 3, 24, 249 over 4. So we have two solutions for this. Minus 15 plus square root 249 over 4, and this one is minus 15 minus 249 square root over 4. What I got for this one is 0.194933, which is rounded off to 0.195, and this one is minus 7.6949, rounded off to minus 7.69. Question number 4. Okay, the diagram shows the graph of absolute fx. Okay, where fx is a cubic function, we can see because of absolute everything is positive. Find the possible expressions for fx. What are the possible expressions for fx? So whenever we have such a graph which is an absolute one, start with this. If they are asking you to find the fx, start with the leftmost side. It is positive, make it negative. Let's assume that this was reflected like this, right? That means there cannot be a shift here. That means a reflection here. It is not possible. So we continue. This becomes the part of the graph then, this one, right? This remains positive. That means that was reflected, but this was actual one, and this is, it reaches here, and the next one, it can't have a cusp like this. So you have to reflect that one also. So this becomes, this red color becomes your fx, and we have to find the equation of this red colored. So to find the equation of this, we should use this one, y equal to a first x intercept, x minus first intercept. It is minus 2 here, so minus minus 2, which is x plus 2 actually. Then x minus second x intercept, which is 1, and third x minus 3. I'm looking at the red graph only, okay, not the reflected one. I'm not looking at this one. I'm not looking at the one which is reflected, this one. All right. So to find the value of a, everything is ready now. We have to find the value of a with the help of this particular point, which is 0, 24, isn't it? It's a y-intercept of the graph. So in place of x, we will substitute 0. In place of y, 24. I will get a, because it is falling on the graph, so it will satisfy the equation. It will be positive, not negative. So 24 equal to 2 times minus 1 is minus 2, and minus 2 times minus 3 is plus 6, 6a. So divide both sides by 6. A comes out to be 4. So the first possible equation of the cubic function is 4. In place of a is 4, and then you can write x plus 2, x minus 1, x minus 3. Let's look at the second possibility. Second possibility is that this part was reflected, right? So this remains our original graph, this part, but we reflect this one. And this one was also original part, but this part was reflected, so we will write here. So this blue color becomes our second possibility, and we will use exactly same method, y equal to a x plus 2 x minus 1 is minus and x minus 3. To find the value of a, we need a point, and the x-intercepts are exactly same. That's why I wrote this. This time if I extend this line, and this point will be reflection of 24, which is minus 24. So we will use minus 24 in place of y equal to a and 0 plus 2, 0 minus 1 and 0 minus 3. In this case, definitely we are going to get a equal to negative 4. So second possible function is negative 4, a reflection of the previous one, x plus 2, x minus 1, x minus 3. B part, what is it talking about? On the axis below, sketch the graph of y equal to absolute 2x plus 1. So like in part 1, we found the original one from absolute. Here let's assume that this is the original one, 2x plus 1. Let's draw the graph of 2x plus 1 first, and then we will take care of the absolutes. So we know this is the format of an equation, y equal to mx plus c. M is the gradient, c is the y-intercept. Let's start with y-intercept. Here the y-intercept is plus 1. So let's say this is plus 1. The graph will pass through this. Now the gradient is 2. This is gradient mx plus c. 2 is the gradient. That means the rise will be 2. So let's say this is 2, this is 3. From 1, second point, rise is 2 and the run will be 1, because 2 can be written as 2 over 1, right? So this becomes our rise, this becomes our run. So here is this run, this is 1. Okay, and now I will connect the 2 points, and that becomes our equation graph. Here it is. Let me make it thinner. Okay, this is the graph, right? But this is the graph of 2x plus 1, not with absolute. For absolute, we will reflect the part which is negative. So from here, I will reflect the negative part upwards on x-axis. So it will become a V shape, and we will erase the one which is negative. So it's gone. This V shape will be the graph of y equal to 2x plus 1. Now let's go to the second one, which is y equal to 4x minus 4, isn't it? If I expand this, it becomes y equal to 4x minus 4. So gradient is 4, y-intercept is minus 4. So minus 4, let's go down, 1, 2, 3 and 4. This is the point from where we will start, because this is the y-intercept. Now rise 4, gradient can be written as 4 over 1. That means rise is 4, run is 1. So rise is 1, 2, 3, 4. We reach as 0 and run is 1. This is the point where we will join the y-intercept. So let me do that. First I will draw it, and then I will erase a part of it for a reason. Yes, this is the line, right? I'm reducing the size of this line because I want to erase the negative part and reflect it. So first let me draw the reflection of this specific part. So it will be somewhere pass through positive 4, right? Because it's minus 4 down there, so positive 4. All right. this is minus, this is positive 4, that is minus 4, right? Now I drew a shorter line because I wanted to erase the negative part, just like the previous equation I did. So two V shapes we got. The graphs, this one is this, and the red color is 2x, absolute 2x plus 1, done. What is the second part of this? Find the exact solutions of 2x plus 1, exactly same, where basically the exact solutions are the points where they are meeting. This and this. And this is solution. Is there any y here? No. Only x's are there. That means we need just the x coordinate. We can use our graph, but I don't think our graph will give us such a correct answer. Okay, according to graph, one answer is x equal to half because it is exactly in middle of 1 and 0. And this one, we can't be sure about this. Maybe 2.5 or 3. Okay, let's say 2.5. But there is an algebraic way of doing this question. Let me do that way. Okay. Whenever we have such a situation when both the parts are having absolute, there's no need to worry. You just write this as a normal equation first. 2x plus 1 equal to 4x minus 4. Because we don't know what is inside, positive or negative. If both are positive, we'll get this situation. If both are negative, they will cancel out and we'll again get this situation. So these two situations are represented by this, and let's find the solution. 2x minus 4x equal to minus 4 minus 1 minus 2x equal to minus 5, and yes, it is giving us minus 5 over minus 2, which is 2.5. That was the assumption here. 2.5 is correct. Now second, another situation could be that this is negative but this is positive, and this is negative inside the absolute signs I'm saying. Okay, but in both the cases they are same, because if I write minus or to the left or the right doesn't matter. So this is what we will use now to find the solution, second solution, and we are expecting x equal to half. So minus 2x plus 1, let's change the sign of this one but keep the other one positive. Minus 2x minus 1 equal to 4x minus 4. Let's take this 4x to the left side, minus 2x minus 4x, and bring minus 1 here, minus 4 plus 1. So minus 6x equal to minus 3, x equal to negative 3 over negative 6, and yes, we got half. So yes, the two answers of these are half and 2.5. We did not take the help of graph. We did it algebraically because they're saying exact solution. Graph cannot give us exact solutions. All right. Question 5. Find the vector which is in the opposite direction of 15 minus 8 and has magnitude of this one. Let's see this 15 minus 8 first. 15 is to the left and minus 8 is down. So that means this is how the vector 15 minus 8 will look like. Positive 15 minus 8. We want a vector which is in opposite direction to this and magnitude 8.5. All right. So first let's find the magnitude of the main vector 15 minus 8. This is how we find the magnitude. So it will be 225 plus 64, which is 289, and which will be in turn equal to 17 units. All right. The magnitude of this is exactly half of 17 because 8.5 is 17 divided by 2. That means the new vector, let's call it vector, okay, x, will be in negative opposite direction. That means negative of the original vector and half the magnitude, and we will write 15 minus 8 inside. This is the original vector. The new vector is opposite direction and half the magnitude, which will be negative 7.5 and 4. That's the vector. Find the values of A and B such that the relationship between the vectors is like this. So we know that the first one in column notation is x, the second one is y. So x can never be converted into y component or y direction of the vector. So we will compare the x direction, x components of each side. So 5 times 3a is 15a from the first part plus 2a plus 1 from the second vector equal to 6 times b plus a. So x components compared. What do we get? 15a plus 2a, 17a plus 1 equal to 6b plus 6a. So let's bring 6a to the left side and this one to the right side. 17a minus 6a equal to 6b minus 1. So 11a. That is equation number 1. All right, let's compare the y components. B, rather 5b, plus 2, this is 5b plus 2 equal to 6 times 2, 12. So we will get 5b equal to 12 minus 2 is straightforwardly. 5b is 10, so b is 10 divided by 5, which is 2. So now we'll substitute that here. So 11a equal to 6 times 2, which is b, we just found out, minus 1. 11a equal to 11, so a equal to 1. Question 6. Write down the values of k for which y equal to k is a tangent to this curve. If we focus on y equal to k, we know that k is a constant. They have already said that it's a constant. So the graph of y equal to k will be a horizontal line. So they have not directly said here, but they are saying find the points where the graph is turning back. Then at that point, that stationary point, the tangent is a horizontal line, right? And for a sine graph, the stationary point is nothing but maximum or minimum, isn't it? So let's draw the graph of this. We know that amplitude of this particular graph will be 4 because that is the coefficient of sine, and the maximum will be axis plus 4. What is axis? Axis is the point number 10. So y equal to 10 is the axis, and we add 4 to this, so the 14 becomes the maximum, and 10 minus 4, 6 becomes minimum. That's how we find maximum minimum. So axis plus amplitude is maximum, axis minus amplitude is minimum. Okay, so 14 and 6. The graph will be between 14 and 6, right? So there is nothing else to do because we already know that at y equal to 14 and y equal to 6, we have stationary points. So the k has two values, 14 and 6. That's it. Next, show that this identity exists, means left is equal to right. So we can see that there are two terms on the left and there is only one term on the right. That means we have to club the two terms on the left to get the right one. Also, on the right side, there is only sine theta. That means this tan theta should be changed to sine over cos. Let's do that. 1 plus sine over cos over 1 minus cos theta plus 1 minus sine over cos theta over 1 plus cos theta. Right? Now, this looks very odd, fraction inside a fraction. So I will do the numerator, this one, I'll focus on numerators only and then I will take care of the denominator. So this one on the left side, can it be written as cos theta over cos theta? So that I can make them same. So we get on top cos theta plus sin theta over cos theta. Because both of them have same denominator now, cos theta and cos theta, we can join them. Now we have over 1 minus cos theta plus, similarly here, cos theta minus sin theta over cos theta over 1 plus cos theta. Now I want to do something, but before that I want to explain why I'm doing it. Suppose I have 3 over 5 over 2. So this is a complete number and this is a fraction on top. If I write divide by 1 and then rewrite it as 3 over 5 times, rather divide by 2 over 1 and then 3 over 5 times 1 over 2. It comes out to be 3 over 5 times 2. That means the denominator of the numerator and the numerator of denominator can multiply. And this one can be ignored because it is just 1. That's what I'm going to do here. So what will I do? This will become cos theta plus sin theta over cos theta, which is this one, multiplied by 1 minus cos theta, which was the denominator. Similarly here, cos theta minus sin theta over cos theta 1 plus cos theta. Now, they have almost similar denominators, but here it is minus, here it is plus. So let's make them same by multiplying here 1 plus cos theta. Here also 1 plus cos theta. Similarly, we'll multiply here 1 minus cos theta. And this whole thing will multiply with 1 minus cos theta. And this also is the whole thing. Now, both of them will have same denominator, which is cos theta is common in both. But 1 plus cos theta, 1 minus cos theta, 1 plus cos theta, 1 minus cos theta. They are in a format of a plus b, a minus b, which can be written as a square minus b square. This is an identity I use many times in my videos. So a square, which is 1 square, minus b square is cos square, because it is a minus b, a plus b, right? A plus b, a minus b. All right. So now, let's open the brackets here, and most of them will get cancelled. I'm sure about this. Then only we can get a simplified thing. So 1 multiplies with cos theta. Let me change it. 1, this one with cos theta. Similarly, 1 with sin theta plus cos theta with cos theta, then cos theta with sin theta, then plus, same thing here, cos theta minus sin theta with multiplying with 1, and then we get minus cos square theta, and this is minus plus sin theta cos theta. All right, now the cancelling time. Cos square and minus cos square. Sin theta minus sin theta. Cos and cos will become 2 cos theta plus cos theta sin theta cos theta, same thing, 2 sin theta cos theta over cos theta, 1 square is 1 minus cos square theta. All right. Now this has cos theta, this also has cos theta. Let's take it common, and both of them have 2 also. 2 will also be common. We are left with 1 plus sin theta here, isn't it? Now divided by cos theta, and 1 minus cos square theta is a very famous identity. It will be sin square theta. Cos theta cancels with cos theta. We are finally left with 2, 1 plus sine theta on top and sine square theta at bottom. And this is what I'm sure they were trying to let us prove. Yes, this is the one. There is a second part where they're saying, hence, solve this equation. Exactly same identity, left side. So we will write the right side that we got in previous part. So 2, 1 plus sine theta over sine square theta equal to 3. Not this, because we have proved that this is equal to this one. Alright, so now let's cross multiply to get a quadratic equation in this case. So 2, 1 plus sine theta stay here, and 3 sine square theta will be on the right side because this multiplies here. So 2 plus 2 sine theta equal to 3 sine square theta. So let's bring both of them to the right side and keeping left as 0. So it will become 3 sine square theta minus 2 sine theta minus 2 equal to 0. It's already there. And now we have to evaluate theta, and factoring is not going to help. So it's better that we use quadratic formula. So in quadratic formula, I will write minus b. B is 2, minus 2 for us. This is b. Plus minus square root b square minus 4 times a. A is 3. C is minus 2 over 2a. Okay, so what do we get here? The first one, 2 plus, and this will be 4, positive 4, this will be 12 times 2, 24, plus 24. So 4 plus 24, 28, square root 28 over 6, and second answer will be 2 minus square root 28 over 6. So if we evaluate them, the first one is 1.2152. There are more digits, but I think 4 digits are enough for this one. And this gives us minus 0.5485. Alright, since this is the value of a sine theta, it cannot be more than 1, so this answer is rejected. Why? Because there is no possibility to get a 1.2152 with the help of sine. That means this is the only answer we'll focus on, 0.5485. And sine is negative. Sine is negative in this and this quadrant, and our answers should be between 0 and 360. Yes, theta should be between 0 and 360, and that's correct. So we'll find these angles. Since negative has given us these quadrants, we'll just write theta equal to sine inverse positive 0.5485, and that acute angle we'll write in the given areas. When I use my calculator, I get 33.29 something, but 33.3 we can write 3 significant figure. This is the final answer, that's why it's okay. So the first answer, theta 1 will be, this is 180 here, and from here we start and reach to the line here, which will be 180 plus 33.3, which is 213.3 degrees, and rounded off to 3 significant figures, 200. Rather, in one decimal place for degrees, it should be one decimal place, so leave it like this. There is no marking scheme out yet, so that's why I'm giving answer this way. The other one will be 360 minus 33.3, because if I start from 0 again, reach to this line, we have not reached 360. It is 33.3 before 360, and that's why it is subtracted. So what do we get? 326 0.7 degrees. This is the final answer. Question number 7. The first three terms of an AP arithmetic progression are these three. So A1 is log 3, A2 is 3 log 3, and A3 is 5 log 3. Given that the sum of n terms in this progression can be written as 256 log 81, find the value of n. So sum of n terms, the formula is n over 2, 2a plus n minus 1 d. Right? What do we know here? We know a. A is a1. So let's write Sn is given as 256 log 81 equal to n over 2 times a1 is log 3 plus n minus 1 d is a problem. For finding d, we can subtract any term from its next term. So let's subtract a1 from a2 and we get our d. So d equal to 3 log 3 minus log 3, which will be what? 2 log 3. And that's what we'll write here. 2 log 3. Now, 256 log 81, let's keep it like this, equal to n over 2. Now, in this bracket, 2 log 3 and 2 log 3 are common in these two terms. So we can write 2 log 3 as common. And what is left inside? 1 from here and n minus 1 from the other part. Right? Now, this 2 and this 2 we can cancel. They are multiplying, so we can cancel them. This 1 and this 1 is cancelled out. So what are we left with? Let's write again. 256 log 81 equal to, now n, and only n left here, so 2n, so n squared log 3. Right? Now, n square keep here. We can bring log, rather let's divide both sides by log 3, which will make it easy to understand. Log 3. So log 3 and log 3 cancel out. Okay. So now, log 3 and log 81. Since 81 is 3 to the power 4, whenever we have such a situation, we can do like this. Let me show you why. I'm doing it mentally, but you can do it like this. Log 81 is written as this way, right? And we have log 3 there. Can this 4 come here? And this 4 is gone. And now we have log 3 and log 3, which can cancel out. So whatever is the power on top, that is the answer of the whole division if both the logs have same content, log 3 and log 3. So we are left with 256 was there and just 4 after that. You can use your calculator because in this part they are not saying that do not use calculator, right? So you can use calculator. I'm just doing it mentally. 1024 equal to n square, square root both sides, and finally n is 32. This is what they were asking. Let's go to the next part, and in that part they're saying do not use calculator. The first three terms of a GP, okay, are ln 256. So A1 is ln 256, not log, natural log. A2 is ln 16 and A3 is ln 4. All right. Find the sum to infinity in this progression, giving your answer in this format. Okay, that is easy. So A1 minus R, this is the sum to infinity, where again a is the first term. So first term is ln 256, so we can write, and we can't use calculator, just keep in mind. So let's substitute s infinity, we have to find out here. So 2 ln 256 divided by 1 minus r. Just like we found d in previous one, by subtracting a term from the next one, here we can divide a term by the previous term. So a2 is ln 16 divided by the previous term ln 256. And now you can know that we can't use calculator, right? I'm finding r here. So I can write this as ln 16 square. Yeah, 16 square is 256. And that's why 2 will come in front, goes from here, ln 16 and ln 16 cancel. We get r equal to half, 1 over 2. And that's what we will write here. So s infinity is equal to 1 minus half, is half. Ln 256 divided by half, which is multiplying by 2, right? This is our answer. This should be our answer, but they're saying we want ln 2 here. So again, a challenge to convert this 256 into base 2. And if you can do it manually, but do not show a sign of using calculator here. I know that 2 to the power 8 is 256, and again this 8 can come and become a coefficient. 2 times 8 is 16. So 16 ln 2 is final answer, where 16 is P. That's it. Question 8, A part. Find the exact coordinates of the points of intersection of these two curves and the line, this line and this curve. Okay, so whenever we have a curve and a line, we know that the coordinates where they are intersecting will be same. So x1, y1 and x2, y2, they will have same coordinates. That means the y value will be same for both. That means the y here and the y in curve can be equated. Let's do that. X square plus 2 square root 5x plus minus 20 is y in the curve will be equal to the y of the line, which is 3 square root 5x plus 10. Now let's collect everything to the left side to make it a quadratic equation. 5x minus 3 square root 5 x minus 20 minus 10 equal to 0. So it becomes x square minus square root 5x. 2 square root 5 minus 3 square root 5 is square root 5 negative minus 30 equal to 0. Since they are saying that we can't use calculator, that means we'll have to use quadratic formula or factoring method. Factoring method will be difficult to guess here, so it will be good to use quadratic formula, which is minus, first of all, let me label. This is 1, which is A, minus square root 5 is B, and minus square root 30 is C for quadratic formula. So minus square root 5, which becomes minus B, plus minus square root B square, minus 4 times 1 times minus 30 over 2a, 2 times 1. So square root 5 plus minus, we get here 5, complete 5, and here it will be 30 times 4, positive 120. So 5 plus 120 over 2. So you can write what? Square root 5 plus minus square root 125 over 2. Now, if you look at this one, we want to use our mental math. They don't want us to use calculator. So we will do what? We'll convert square root 125. Let me do here. Square root 125 can be written as a perfect square 25 times square root 5, which is square root of 20, square root 25 is 5, and then we have square root. That means we can convert this to 5 square root 5. So our first solution should be 5 plus 5 square root 5 over 2, and this is not 5, this is square root 5. Okay, so it becomes square root 5 over 2, 2 and 6 cancel, we get 3 square root 5. That is our first solution. Second one, square root 5 minus 5 square root 5 over 2, which is minus 4 square root 5 over 2. 2 and 4 cancel. Answer is minus 2 square root 5. These are the two solutions for x. Alright? But if we look at the question says find the exact coordinates. That means we have to find y coordinate as well. Let me select the easier option, which is line, to find the y coordinate. The line's equation was 3 square root 5 x plus 10. So let's substitute the first answer, which was 3 square root 5, and the answer was 3 square root 5 again, plus 10. So 3 times 3 is 9, and square root 5 times square root 5 is complete 5. 9 times 5, 45, plus 10, which is 55. First point of intersection comes out to be x coordinates 3 square root 5 and y coordinate 55. What was second? Y equal to 3 square root 5 and the x value was minus 2 square root 5 plus 10. 3 times 2 is 6. 6 times 5 is 30, negative 30, plus 10, which is minus 20. So second point of intersection comes out to be minus 2 square root 5 minus 20. Alright, what is next? B part. They have given you tan theta, and theta is between 0 and pi by 2. Find cosecant square theta, and this format should be there. Okay, there are two ways. Let me take the difficult one, which is assumed to be difficult, but it is not exactly difficult. Alright, so we know we want cosecant square theta, correct? There's an identity that cosecant square theta is cot square theta plus 1. We also know that cot theta is 1 over tan theta. And this is the fact we will use to solve this equation. So, this is what we need, and we, in place of cot, we will write 1 over tan. So it becomes 1 over tan square theta plus 1, right? Now, tan theta is given to us, and this is reciprocal of that. So we will write reciprocal of what they have given. So 2 plus square root 3 comes on top, and square root 3 minus 1 becomes denominator, and we square it plus 1. And just we have to simplify this. That will become our solution. So let's square this numerator first, and we will use straight away the identity we know. A plus b square is a square plus b square plus 2ab. So a for us here is 2, so 2 square is 4, plus square root 3 square is 3, plus 2ab, 2 times 2 is 4, square root 3. Now here we will use a minus b. In place of plus, it will be minus, and in place of this, 2ab will be minus. A square plus b square minus 2ab plus 1 is already there. So we get here 7 plus 4 square root 3 over 4 minus 2 square root 3 plus 1. Okay, can we club these two together by, or rather, let's leave 1 alone for the time being. Okay, let's keep it aside and we will take care of this later. Let's rationalize the denominator here. 7 plus 4 square root 3 over 4 minus 2 square root 3. We will rationalize the denominator by multiplying the conjugate of it, the denominator, up as well as down. So let's complete it here. Plus 1 is kept aside. It will be 7 times 4, 28. 7 times 2 square root 3, 14 square root 3. Then 4 square root 3 times 4, 16 square root 3. And then 4 square root 3 times 2 square root 3 will be 4 times 2, 8. And square root 3 times square root 3 is complete 3. 8 times 3, 24. Divided by. Now we can use the identity, this one here, a minus b, a plus b equal to a square minus b square. So this is a minus b, a plus b format. So a square, 4 square, 16 minus b square. Square of 2 square root 3 will be 4 times 3, 12. So what do we get here? 52, 14 plus 16, 30 square root 3 over 4 plus 1. So let's separate the numerators in this one. 52 over 4 plus 30 over 4 square root 3 plus 1. 52 divided by 4 is 13 and 13 plus 1 will be 14. That's why I did not touch 1. Plus this will cancel out, 15 square root 3 over 2. This is the solution of this particular question. Next, a circle of center O has a sector OAB. Alright, R is the radius. Area is 10 centimeter square for that sector. Okay, so let's draw the circle here. Alright, so we have center O and then we have a radius R. This is angle theta. That's what they say. Theta radians. The perimeter of the sector is P. Alright. Find the expression for P in terms of R. So first they have given the area. Right. Fixed area of 10 centimeter square. So area, which is half theta R square, is 10. This will help us to eliminate theta because they're saying find expression of P in terms of R. That means theta should not be there. So let's isolate theta here. So what will happen? These two will go and multiply with 10, 20. R square is a numerator, becomes denominator on the other side by cross multiplication. Theta is in terms of R now. They're asking us to find the perimeter. Let's see what is the perimeter in this case. Perimeter will be this length R plus this length R. So R plus R plus this arc. The formula for arc is R theta. So this will be the perimeter, but we don't want theta. So what are we going to do? We will eliminate that one. So perimeter becomes 2R plus R, and theta is 20 over R square. R will cancel with one of the R's. So finally we got it. P equal to 2R plus 20 over R. That's it. What is B part? Find the value of R for which P has stationary value. Okay, stationary value means the first derivative will be equal to 0. And that's what we're going to do. We will find the differentiation of P with respect to R, dP over dr. So 2R, what is the differentiation of 2R? Just 2 plus 20 over R. So let's do it here. 20 over R. Twenty over R can be written as 20 R to the power minus 1, right? And I will differentiate this. Minus 1 will come in front. 20 remains 20 because it's a constant, and R's exponent will go down by 1. So what do we get here? 2 minus 20 over r square, because minus 1 is minus 2. To make it positive, I make it a denominator. This has to be equal to 0 for stationary value. And we'll just solve it now. So let's bring 20 over r square to the left side, which is equal to 2. Cross multiply, 2 comes down, r goes up. So what do we get? 20 over 2 equal to r square. So square root 10, r will be square root 10. Find the value of r. So they are not saying whether it is, we want exact or decimal. You can convert it to decimal, which will be about how much? 3.1? About 3.1. But I will use this for further calculations. Determine the nature of this stationary value. Okay. Okay, this is stationary value. Find the value of r for which has stationary value. Okay, so r we found out. Now we have to find its nature. To find the nature, we always differentiate it once more. Second derivative, d square p over dr square will be differentiation of 2 will be 0. Differentiation of this is minus 20 r to the power minus 2. So minus 20 minus 2 r to the power minus 3. This will be the differentiation. So it will be 40, positive 40 over r cube. This is the second derivative, but this is the value of r, we have to substitute that. So at r equal to square root 10, it will be 40 divided by square root 10 cube. Alright, so to find the nature, it's not important what is the value. It is important what is the sign of this value. And definitely it is going to be positive, because 40 is positive, square root of 10 cube will also be positive. So we are getting a positive number. That means your graph or curve is opening up. The value we just got is a minimum. So nature of this is minimum. Find the value of theta at this stationary value. Okay, and theta, if you remember, it was 20 over something, 20 over r square. Look, this one. So we'll use theta equal to 20 over r square, which is 20 over square root 10 square. Square and square root cancel. Theta is 2 radians. Alright, 10th and last question. The normal to the curve y equal to tan 3x plus pi by 2 at a point P with coordinates P minus 1. Okay, so let's try to visualize this. So this is x-axis and the graph of tan is always like this, right? P minus 1 minus x, y coordinate is minus 1. So let's hope that this is P minus 1. Okay, between 0 and pi by 6 meets x-axis at point A, the normal. Okay, they're saying the normal of the curve. So normal will be somewhere 90 degree to the tangents, like this. So it is meeting x-axis at A. And y-axis, I don't know where is the y-axis, but let's see y-axis is, suppose, here. So it meets y-axis at this point. So this is A, this is B. I have drawn randomly, please don't take it serious, just I want to visualize this. Find the exact coordinates of the midpoint of AB. Midpoint of AB, suppose this is midpoint of AB, let's call it M. They are saying what are the coordinates of M, right? So to find, let's go backwards, to find the coordinates of M, we should know the coordinates of A and B. To know the coordinates of A and B, we should know the equation of the normal. So let's find the equation of normal. So equation of normal to a curve is y minus y1 equal to minus 1 over m x minus x1. where x1, y1 are the coordinates of any point on the line, and P is the point we'll take. And M is the gradient of tangent, which is dy over dx. So let's find dy over dx, gradient of tangent first. So gradient of tangent, M, dy equal to dy over dx. Okay, let's differentiate y equal to tan 3x pi by 2. Okay, so tan, the differentiation of tan is secant square same angle 3x plus pi by 2, but we have to multiply this whole thing another differentiation of the angle, which is 3. So it becomes 3 secant square 3x plus pi by 2. Now, we know the y coordinate of this point P. What about x coordinate? I need x coordinate to be put here. So to find x coordinate, let's use the main equation, which is y equal to tan 3x plus pi by 2. We know that the y coordinate of P is minus 1. So let's minus 1, let's write minus 1 here, tan 3x plus pi by 2. So 3x plus pi by 2 is tan inverse minus 1. Since they're saying our x is between 0 and pi by 6, no. P is between 0 and pi by 6, which is x in this case, x coordinate, right? So let's use the quadrant which is closest to this range, and tan is negative, right? Tan inverse negative 1. So tan is negative here and here. So this will be the quadrant we will be using because it is closest to 0 to pi by 6. Now we can find this angle by tan inverse positive 1 because quadrant is with us now, which is pi by 4. Tan inverse 1 is pi by 4. So the angle of our requirement is this angle from 0 till here, which is pi minus pi by 4. So 3x plus pi by 2 is equal to pi minus pi by 4. 3x equal to how much? 3 pi by 4 minus this pi by 2 also goes to the other side. So 3x equal to pi by 4. You can use your calculator. So 3 pi by 4 minus pi by 2 will be pi by 4. That means x is pi by 12. Is this between 0 and pi by 6? Of course it is. It is half of pi by 6. So x coordinate of P is pi by 6 and minus 1. These are the coordinates of P. And this is what we are going to use to find dy over dx m here. So m comes out to be 3 secant square 3 times pi by 12 plus pi by 2. This 3 and this cancel 4. Okay, secant square is not in our calculator, so what will we do? We will write m equal to 3 over cos square, and pi by 4 plus pi by 2 will be 3 pi by 4. So please keep in mind 3 will not be reciprocated because secant square we are reciprocating to get cos, which is 1 over cos square, so 3 will remain the numerator. So what do we get here? M comes out cos square 3 by 4 will be square root 1 over square root 2. Let me see. Use my calculator for this. It comes out to be 6. Complete 6. So now our equation we started with, equation of the normal was y minus y1 1 over m, this one. Okay, so we will use it now. Y minus y1. We know the y1 now. The point has coordinates and we know those coordinates now. Equal to minus 1 over m, which is 6 now. X minus the x coordinate of that point was pi over 12. P. Right? So now, this is the equation of the normal, but that's not what our final destination was. Our requirement was to find the coordinates of A and B. So A is the x-intercept of this line. For x-intercept, we put y equal to 0. In this equation, for x-intercept, which is point A on the graph, we put y equal to 0. So 0 plus 1 equal to minus 1/6 x minus pi by 12. So this is gone. So 6 will go and multiply here, minus 6 rather. So minus 6 equal to, this minus is gone, x minus pi over 12. So x will be pi over 12 minus 6. And obviously it will be a negative number, and we can see that was on the negative side, so it makes sense. This is x coordinate of y x-intercept. So the coordinates of A will be pi over 12 minus 6, that is the x coordinate, and of course y coordinate is 0. To find the coordinates of point B, which is y-intercept. For y-intercept, we put x equal to 0 in the same equation and we'll get the coordinates. So equation was y plus 1 equal to, okay, for point B, which is y-intercept. It will be y plus, and we'll put x equal to 0. Y plus 1 equal to minus 1 over 6, 0 minus pi over 12. Okay, so y equal to minus 1/6 and times this will be positive pi over 72 and minus 1. This plus 1 will go to the right side, becomes minus 1. This becomes the y coordinate of y-intercept. So point B becomes 0, pi by 72 minus 1. We got the coordinates of A and B. Now, let me visually write this somewhere here. So there is point A, coordinates are pi over 12 minus 6, comma 0. This is point B, its coordinates are 0, comma pi by 72 minus 1. Alright, and we have to find the coordinates of the midpoint. So, coordinates of midpoint will be pi over 12 minus 6 plus 0, because this is 0, right? Add these two coordinates, divide by 2. And comma 0 plus pi over 72 minus 1 divided by 2. Let's see what is the final answer. So, let's divide it. Are they saying exact value or decimals? Let's see. Find the exact coordinates. Okay, so no need to convert to decimal. Just divide by 2. Pi by 12 divided by 2 will be pi over 24 minus 6 divided by 2 is 3. This is x coordinate, comma 0 is excluded. Pi over 72 divided by 2, pi over 144 minus 1 over 2. These are the coordinates of the midpoint.